Quick question for you. You have a piece of metal and you heat it. What happens to it? Well, we all know it expands, and it expands in all directions. What happens then if there is a hole in that piece of metal? What happens to the size of that hole? Give yourself a second to think about it. Well, one way of looking at it is to think, well, the material is expanding in all directions, so surely it's going to expand that way as well, and it's going to fill the hole up, and the hole's going to get smaller. But no, it doesn't. Why is that? Well, if you imagine around the hole, you have a load of atoms sort of joined up, effectively holding hands around the edge of the hole. If they move towards the hole, they're going to get closer together. Only fractionally maybe, but they will be getting closer together. And so they obviously must get further apart. So this is very much true. If you are an engineer, you'll know if you heat up a crankcase and it's got a hole in it for a bearing, what you need to do is heat that crankcase up, cool the bearing down, and the bearing will fit nice and snugly. And then when you get it all back to temperature, the casing will shrink, the bearing will expand, and they'll have an interference fit and the bearing won't come out again. So that's very useful to know. One thing which is, so if you're heating, say, a tube with a bolt inside it, what you have to be careful of is you want the tube to get hot, but you want the bolt inside to stay cool. Same as if it's, I mean, that tube could be anything, could be a brake caliper. But basically what you're wanting to do is to not do what you see so many people doing and put a blowtorch onto the bolt here. You actually want the heat focused here. You want the heat in the body of the thing which it's going into, and you want to be trying to keep this as cool as possible. It's the reason why things like shock and unlock work quite well, because they're freeze sprays. So a freeze spray, you want to spray on the bolt itself